Hello, my name is Flavia Darqui and I am a biotechnologist. I work at the National Institute of Agricultural Technology in Argentina. When the Berlin Wall fell, I was 2.5 years old and I was visiting the Perito Moreno Glacier. When I was a child, I wanted to be a writer. Although I am not, I have written some scientific articles, research projects, and funding requests. This project will break the wall of developing a biopesticide from quinoa desaponification waste. What is the challenge your project addresses and what is your solution? The challenge is that although the international demand of quinoa is growing, especially in the health food market, its production has an important barrier, which is that the outer shell of the grain contains a high concentration of anti-nutritional components called saponins that must be removed before marketing. This process needs an infrastructure specially adapted to the quinoa grain, and it's scarce. Besides, only a large bulk of quinoa grain will compensate for the processing cost. However, these currently waste saponins have biopesticidal activity, and currently most crops, pests, and disease are controlled with chemical pesticides, which can be harmful to the environment or people's health if they are used wrongly. In this context, bio-based pesticides are a much more sustainable alternative. The broad idea would be to integrate the storage, cleaning, desaponification, and packaging of quinoa grain, along with the extraction and concentration of quinoa saponins, to obtain three main products: saponin-free quinoa grain for human consumption, quinoa saponin extract for the formulation of biopesticides, and the saponified quinoa husk for animal feed. The project is based in a green and circular economy strategy, where resources are used in a sustainable way, optimizing production and increasing the value of quinoa and its byproducts. The first stage of the project, this is to achieve a biopesticide prototype, requires only a low initial investment, which could be obtained through a research grant. The production method is rather simple and it requires simple technology. The products will be obtained from processing local raw materials, so there is less cost risk associated with exchange rate variations. The saponin-based pesticide is very stable compared with other biocontrol agents. As it doesn't contain any living organisms, it will reach a longer shelf life and it will be easier to transport and store. Also, there will be no need to use a fermentation system for biomass production. The project will provide a new biopesticide for the local biopesticides market, which is very small in Argentina. Biopesticides are safer because of their lower toxicity, higher precision, and faster decomposition, being a more sustainable alternative than chemical pesticides. For manufacturers, biopesticides imply lower costs in regulatory processes. For producers, they are effective for pest control while minimizing the appearances of resistances. Also, the new generation of consumers is demanding for better quality foods, free of pesticide residues and sustainably produced. Thus, food markets are asking producers to look for more ecological alternatives. This project will also benefit quinoa producers as it will contribute to increase the economic value of quinoa and its byproducts, promoting local production. One of them is that the biopesticidal activity of quinoa saponins is largely described in scientific literature, and also a quinoa saponin-based biopesticide is already registered in the United States with a related patent that is expiring soon. So the inability to protect the product with an invention patent could, to some extent, discourage private investments. It is also necessary to test the level of effectiveness of the biopesticide against local pathogens and national crops. Another issue to be solved is that there is little background on using biopesticides in Argentina and a lack of experience in the biopesticides market.